Hi guys, this is the third video of a 5-part Docker 101 tutorial. Check out my other videos to give an idea of what Docker is and how it is built. In this video, I'm going to explain to you the major Docker objects such as Docker image, containers, Docker files, managing data in Docker, and Docker networks. So let's get started. Docker image is the fundamental object residing in the Docker build. Without this, all the other Docker activities are not possible. An image is a read-only template with a set of instructions for creating a container. It contains source code, config files, environment variables, libraries, and runtimes as such. Now, to build an image, we need to create a Dockerfile which has very simple syntax and run it. So, each instruction in Dockerfile creates a layer in the image. A layer is nothing but a file generated by using a command. In this case, from Ubuntu 18.04 is a command, and this generates a layer 1, like so. Now the next command will generate another layer, and so on and so forth until the command is arrived. So while updating a Docker file and rebuilding it, only those layers are recreated. So in this case, I have mistyped the command instruction, and I'm recreating the command instruction and building it so that only this layer is regenerated. This is what makes Docker powerful in comparison with other virtualization technologies. The next object is a Docker file. And Dockerfile is the method of choice for real-world container deployments. It is systematic, flexible, and efficient to build a Docker image. Here you see an example of a Dockerfile, and here in the middle you see the commands used in the Dockerfile. Pause the video here and have a look at the commands. When we talk about Dockerfile, dockerignore is another file which will be useful in many cases. We don't want certain files to be stored along with image. For example, API keys, environmental files, etc. To exclude these files, dockerignore file must be created alongside the Docker file. It plays an important role in creating more compact and faster running containers. In this example, we see the folder.git, node modules, and so on will be excluded while building the image. This works also in similar fashion to git ignore file. So the next object which we are going to see is a Docker container. Container is a runnable instance of an image. This can be accessed by Docker API or CLI to start, stop, create, move, or delete a container. You can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. By default, containers are well isolated from one another. If you start a container with an image, a thin writable layer will be created. Thin writable because any modification during the lifetime of a container are stored in this thin writable layer or the container layer. We can also start a second container based on a similar image. This way, the containers are also isolated from each other, and it exactly knows which base image to be started from. Containers are defined by the images as well as other configuration options set at the time of creation. When a container is removed, the data stored within the container layer is also removed. That means the data is not persistent. So now I'll show you how to persist the data and what possibilities are available within the Docker environment. To persist the data, Docker provides two options. One is the volumes. Volumes are most efficient way and the recommended way to persist the data. The data resides within the Docker area within the file system. That means the container does not have access to the file system. The second option are the bind mounts. Using this method, the host's file system or directory is made accessible to the container. This allows non-Docker processes to modify the host's file system and could cause unwarranted calls for security concern. Docker also provides the possibility to store data in the host's memory. This is only available within the Linux environment. For example, Swarm Services uses tempfs mounts to mount secrets into the service containers. Named pipe, available only in Windows Docker hosts, can be used for communicating between Docker hosts and containers. Common use case is to run a third-party tool inside the container and connect to the Docker Engine API. So the next Docker object is the Docker networks. Communication between Docker containers services to communicate with each other or other non-Docker workloads. There are 5 types of network drivers which is shipped along with Docker Engine. Bridge is the default driver and is useful to communicate between multiple containers within the same host. It also provides a possibility to access containers via ports from external network. Host networks are useful when you want to isolate all the other aspects of the container except the networking part. MAC VLAN, on the other hand, assigns unique MAC address to the container and makes it looks like physical host. Overlay networks connect multiple Docker hosts and its swarm scope driver rather than individual hosts. Last but not least, none driver disables all networking and is usually used in conjunction with custom network driver. Third-party network plugins can also be installed and used with Docker. They are available either in Docker Hub or from the third-party vendor directly. So, in this video, we have seen different Docker objects like images, containers, and managing data within the Docker world, and also networking. In the next part, I will show you the basic and important commands to work with Docker. If you like this video, give a like and subscribe to my channel for more videos.